So last time we were talking about mathematical induction. So we're going to continue that discussion. So let's start. We're going to do another problem. But now we're going to look at a recursively defined sequence. So define a sequence. A1, A2, A3 as follows. So the first term in your sequence will be 2, and then every term after that will be defined by this formula. AK is 5 times, it's 5 times the previous term, AK minus 1, and this formula is true for every integer k greater than or equal to 2. So there's two parts to this. So first we want to write the first 4 terms of the sequence. So the first term was given to us, A1 is 2. So let's find A2 now. To find A2, you're going to use this formula right here, and you're going to plug in k equals 2. So it'll be 5 times A1. So this will be 5 times 2, which is 10. You're going to use that formula again for A3. So if you plug in k equals 3, it's going to be 5 times A2, 5 times 10, or 50. A4, if you plug in k equals 4 into that formula, you'll get 5 times A3, 5 times 50, or 250. So here, my first 4 terms are 2, 10, 50, and 250. Now, if we start to look here at these numbers and factor them, so A1 is 2, A2 was 10, which is 2 times 5, A3 is 50, which is 2 times 5 squared, A4 is 2 times 5 cubed, 125. And so we start to notice this pattern. So then what we want to do is we want to prove that AN equals 2 times 5 to the n minus 1 for all n greater than or equal to 1. So if I want to prove this, remember that this kind of thing, we're trying to prove a formula here. So this requires induction. So let's start. Remember, induction has 2 parts, and you always start with the first part, the basis step. So let's start there, the basis step. You want to establish that the formula is true for the first value. So the first value here is n equals 1. So if I plug in A1, n equals 1 into that formula, I get 2 times 5 to the 0th power, which is equal to 2. A1 was equal to 2, so this is true. That means our formula is true for the initial value. So that completes our basis step. Now let's do the inductive step. So we need to assume that the formula is true for an arbitrary integer, k. Let k be any integer. where k is at least as big as your basis step, greater than or equal to 1. And suppose we're going to assume that the formula is true for k. AK is 2 times 5 to the k minus 1. So now what do we have to do? We have to show that the formula is true for the next value. So the next value would be k plus 1. So let's write down, we must show that AK plus 1 equals 2 times 5 to the k plus 1 minus 1. Or if you simplify that exponent, it's just going to be 2 times 5 to the k. Okay. Well, what did we say about k? K was at least 1. Since k is at least 1, that means k plus 1 is at least 2. So we can use our recurrence relation for k plus 1 using the recurrence relation. We have, so AK plus 1, using the recurrence relation, it's 5 times the previous term, which would be AK. And then we can use, so for AK, we can use this formula right here. So this will be 5 times 2 times 5 to the k minus 1. So we're going to get 2. And this 5 is really 5 to the first. And when we combine these two, we add the exponents together. So you're going to get 5 to the k. And that's exactly the formula we needed to prove. So we've established that that formula is true by induction.